All right, so presenting next will be Tori Green on behalf of Yang Zhang and John Isaacs. We presenting modular 3D interface design for accessible VR applications.
Good. Can use this, right? Okay, cool. So I think this is actually going to be really topical based off the previous two presentations we've just watched. So I'm going to do a quick presentation on the modular 3D interface that's been developed. The outline of the presentation is essentially going to be go over the problem space within 2D existing interaction designs. And then I'm going to go into the design philosophy behind this 3D module interface. And at the end, I'll go over a small focus group that was completed. So the problem that was identified was that we've primarily been interacting with VR interfaces using a laser pointer in the form of a raycast, which is very similar to that of a traditional cursor that we use in a Windows icon menu pointer interface. And game developers are left using their discretion for implementing new mechanics based off of their game design vision. So is there a better way that we can kind of translate input to the user? On screen here are two scenarios from Half-Life Alyx, which is a world-class immersive experience. The placement of the UI in front of you there, you can see the player is in a fixed position where the UI is static as well, meaning that they can't walk around the environment. They have to stay here in order to interact with the interface. As you can see there as well, we have buttons and sliders and context windows that pop up, and that looks very similar to what we see in traditional interface design today on desktops. In the bottom right-hand corner, we can also see a spherical mini game in the game where the user is using a 3D object along with another raycast in order to dodge the red enemies around the ball. So that's where we're seeing a unique game mechanic being integrated by the developers in 3D space. So I wanted to consider the possibility that there is an alternative means of general interaction within VR other than using a ray-based interaction approach. The reason why we're using ray-based interaction approaches is because we've adopted it from 2D traditional design mediums, allowing developers to have a very intuitive way just to interact with the environment that they're in. So if we were to remove this, entirely, then we're left with perhaps our proprioception ability, which is our ability to understand where we are in 3D space. This is another natural, intuitive form of interaction where we're actually being able to use the 3D environment as we would interact with objects in the real world. And the study that I completed at the end here was just a small focus group of 6 people focusing on high usability and low usability satisfaction within regards to the interface itself. And the interface that's been developed is to empower the user to choose where they want interface elements to be, and leaves developer discretion for the placement of fixed UI as like a thing of the past. So the 3 key concepts of the interface itself is it's powered by the physics engine. In real life, we interact with the real world based off of physics. We use our intuition to understand where objects are. A mechanic doesn't need to look where his toolkit is when he's under the car bonnet. He knows exactly where the next wrench is he needs. This is kind of the design idea that kind of drove this forward. Kinematic panels are the little toolbar you can see on the left, along with the slider. They're free floating in space, and they can be adjusted by the user at any time. And the contextual based off of the user and the environment, there are interfaces for the user and interfaces for the environment, and I'll go into that in a little bit more detail shortly. So in order to actually run a user study in this, I needed to develop some sort of vehicle to present the interface itself in. Otherwise, we're not going to be able to get a high and low usability satisfaction if we just have sliders and buttons without any valid response. So I decided to create a 3D topographical map with a GIS spatial data set where I scraped all the EV chargers around Scotland at 15-minute intervals for 6 months. And then you're able to query it and see what chargers were online, offline, and what specific charger types. The information that was also stored inside those little electric bolts there, which is designed to be that of a skeuomorph, where we can kind of use 3D objects to understand exactly what context and what information it could contain, we're using LiDAR, video, photogrammetry, which is just meshes, and of course audio as well. So users were able to navigate around the world and experience any city or location they wanted. So to go over the three main pieces of the interface, the kinematic panels here. On the left-hand side, we can see we have the original design concept, which is kind of taken from the iPad or the tablet. And we're looking at clipboards as well, where we use one hand to hold and the other hand to interact. But then I kind of questioned why that would be the case. We want to create a forgiving interface that empowers the user to interact with elements as they choose. Perhaps the accessibility constraints for temporary and long-term accessibility issues would prevent a user from reaching over and grabbing it from one side. So a key factor for the three interface elements I'm going to describe here is that it was developed with an accessible first design philosophy, trying to question how users would have using physical personal personas and how users with specific elements may not be able to interact with the system. And that's where the multi-model approach comes in. The slider was quite a fun exercise to do. At the top right there, we can see a traditional 2D slider. And then I just converted that directly into 3D with a spring joint there using a combination of Hooke's law and the Unity spring joints that are in the engine. And that was as forgiving as you could get. And then I decided to add some constraints onto the slider. And that's where we can see it's an anchor point in the middle, followed by a scale where the value will scale to the right and left accordingly. As it's built off the physics engine, we're able to interact with any rigid body. So if your hands have a rigid body on it, you're able to just use your fingers and slide across. There's also constraints where the user can grab the anchor point and move it around at a distance, and then it will eventually become disconnected. This just prevents you having to be very fixated on a specific point in order to interact with the anchor point, again, focusing on accessibility and a forgiving interface. The panels here, you can see their opacity with some translucency. The reason is because I think that this could be transferred into augmented reality as well. We're trying to make it feel like a natural, fluid environment, and we don't want to occlude the task that the user is interacting with. Of course, you have to take into design considerations with colorblind and what color is the environment that the user's in just now. As you can see, they'll be bleeding otherwise. So this is just a preliminary design stage, really. But opacity and translucency is something I'm definitely a fan of in an immersive environment. So the buttons is nothing too novel here. This is starting to become quite a common interaction mechanism in many VR games just now. It is just using a rigid body with a spring joint, again, allowing you to navigate through the sliders. The control mechanism used was using a Valve Index controller, and this allowed for full hand tracking capabilities where there's a strap on the controller and you don't need to worry about dropping the controller, as it also provides haptic feedback. If you're just using hand tracking, you don't have any haptic feedback, so you have to rely on other mediums of feedback to the user. And this is something that was raised as quite an important usability satisfaction part of this focus group, where haptic feedback via visual, auditory, and also physical feedback was important to understand that the user did press a button and they did interact with the slider. The interface is contextual as well. So the UI can be displayed and hidden. So that's why you can see there on those two buttons on the right, we have lock and display. That's the only interaction that you really need on the controller. You can use the environment and walk around in a one-to-one scale. The joystick is just used for teleporting and walking around, but the reality is those two buttons there that could be used via voice controls as well, show UI, hide UI. So that's not critically important to actually use a controller. So the idea here is that it's developing an interface that can be compatible for future sensors that we'll be able to integrate up future sensors that we'll be able to integrate into the headsets. So the contextual interface is based off of the context of the user and the environment. And I think this is an interesting area to explore. As you can see on screen, we have zones 1 and 2. In zone 2, we have a video player, scrubber, and play and stop button. And in zone 1, we have all of the interface panels to interact with the map itself. There's no reason for us to have the interface for interacting with the map in zone 2, because we're far away from the map. The user isn't going to be over there, so it's fixed in 3D space at that point. And for the video, their user is going to be pretty far away to view the video if they're in zone 1. So the idea here is that there's going to be interface elements that is always going to be in context of the user, locked to their position, like escaping the experience, adjusting accessibility features, perhaps changing audio and haptic feedbacks. But then also there's going to be UI that will be fixed in the environment where when the user enters zone 2, then the button for the play appears. They don't need to be obfuscated with a bunch of menus that they're not actually going to get access to. And this is where the natural interaction matrix comes in. I'll go over this quite briefly. It's a concept that every development is to break down the design requirements for an interaction in virtual reality. So where we have a requirement here, the requirements up there, scaling, navigation, selection, and move, they're taken from Big Data Visualization Challenges and Research Agenda paper. And this is the key requirements that was established for a big data visualization platform. And they can be broken down into travel, selection, and manipulation. That's how you could break down all VR interaction, to be honest. I'm not sure how you would go any further. So combining those two from the two different papers, you can actually say that there's a magic or high fidelity interaction medium. If you're going to navigate around the environment, a high fidelity interaction medium would be a one-to-one tracking. You're physically walking in the real world. In the virtual world, you're walking forwards. A magic equivalent of that would be teleportation. We're using software in order to have teleport, or using the joystick even, which can be a hybrid of the two, but considered a magical mechanism for travel there. Again, another scenario would be driving a car. If you're in front of a wheel in a virtual reality and you're turning like this, that's considered a high fidelity interaction. And if you're using some other form of interaction, then it's considered a magical interaction. So just to kind of finish up for the focus group discussion happens, it is a multimodal input interface. So we're able to use eye tracking thanks to the Quest Pro now, which has it built in natively. We're able to look at the icons and select them. And what this allows for users who are potentially have minimal mobility is for the panels to be presented on top of them. If they're bedbound, for example, they're able to use their eyes and navigate through the menu and select them using a variety of input, again, audio and microphones. It was a really good one. Because we have eye track foveated rendering as well, this eye tracking is going to be here to stay forever, and I think that it's important to consider if we're going to develop an interface for moving forward. We need to consider gaze as being almost a primary form of interaction. Awesome. So the focus group consisted of just 6 people. This is a preliminary focus group that ran for about an hour and a half. So there's a lot of information that came from this. It was targeted to VR users who had minimal to some exposure to virtual reality. And the reason for this was we wanted to remove any bias that the user might have towards a specific means of interaction. If they've never used a ray-based interaction before, then perhaps that they might actually find it really rewarding just to use 3D. One of the users who did participate in the study who had played VR before, when they went in, they instantly tried to look for the ray to interact with everything. It's like, you don't need to do that in this one. So it was kind of to guide the users throughout the experience. It was to be as natural as possible. And just to touch over the high usability satisfaction, users enjoyed being able to move the panels wherever they wanted to. They enjoyed being able to walk between around the environment with the UI following them as they're going around the environment, and then hiding it as when they prefer. The tasks that they wanted to do were just completely open to them: navigate with the map, explore the world, interact with the gravity. And the low usability satisfaction there was primarily setting up the headset and also resulting into haptics. So haptic feedback was critical in order to let the user know that they've interacted with the interface. And we used the thematic analysis, again, haptics, multimodal input. And the next steps is to probably run another focus group, but I think I'm going to release this into a commercial application in a video game. So here's just a short little video there that just shows you how it works. And there's always going to be plenty of room for improvement, but I definitely think that having a vehicle in order to sell this interface is an important aspect. So yeah, thank you. Any questions?
So really cool stuff. 2 quick questions. The first one for the eye tracking how does the user like actually select things? Is it based on
Yep.
time or blinking or something like that?
Yeah. So one input medium is what I've kind of established what can happen. For the focus group, voice and eye tracking was not used. Voice and eye tracking was excluded from the study for this. That was just because the pro wasn't out when the study was completed, and you need an external peripheral for this. A single gesture, looking, pressing a button. I also think that, musicians have the little buttons they can put in their mouth when they change tracks and make loops.
Yeah.
I actually think that's a brilliant form of interaction. It just takes a 3.5mm audio jack to interact with that. So I think any selection. But for mic specifically, not quite eye tracking, it's just an ID, a key identifier followed by the button. So CSS panel, right, so it's just two words is kind of what I think is the best form for that.
And is there any way to download this as like a Unity package?
Yeah, if you go on my website, there's a demo. It's using the James Webb Telescope, images from the James Webb Telescope, and then you can just kind of select the images you want via the panel. I think there's an update coming to that in shortly. So, yeah.
Thank you.
Thank you. This was really good. My question is about hand tracking, and are you going to do a study with hand tracking, and are you looking at using like tack gloves or anything to provide the haptics that you usually get from controllers for that?
Yeah, I have tried this with just hand tracking using Quest 2. It's very simple to implement just because it's using rigid bodies. So your hand already has the rigid bodies when you have the pass-through kind of enabled. Something to think about. I haven't tried it, but I've tried it, but I haven't thought about doing a study with it. As far as haptic feedback gloves, yeah, I'd love to. I'm kind of waiting to see what Valve's Decard, see what peripherals they're going to release for that controller, because maybe there'll be something innovative there that we can integrate. But yeah, both valid points and something to explore, definitely.
So just quick, I'll let you know that you can record gestures very easily with the SDK through Meta, so that the hand tracking becomes very natural and fluid. And the tack gloves are like $300 and they're really good haptic.
Tack gloves, okay. Yeah.
Yeah.
Are you talking about hand posing? Yeah. Oh yeah. Hand posing. So this doesn't use hand posing. This does use there's no fixed, it is just grabbing. Do you know what I mean? So it's just tracking your fingers, so you're able to do that. Hand posing is quite good for selecting objects as well. It's something to think about. Indeed. Yeah. Very good. Thank you.
This may be the same question, kind of, but I did notice you were rotating objects on screen, and I was imagining that was happening by hand posing of some kind. Could you say a little bit more about if that presented any challenge, or and how that aided the experience? I think also.
Okay, so like regards to like a video here, like moving the objects around,
moving the objects around, and then changing their dimension that they're in.
The position.
The slider is moving from horizontal to vertical in some cases.
Yes.
And things like that.
So I think quite a common thing in UX design, they say like verticality, yes, horizontal, no. But what we're trying to do here as well is the slider had quite a lot of design concepts that came in from preventing a lot of shoulder movement. So just kind of focusing on elbow and downwards. And obviously going like this as well, that's like a cockpit in a flight. So again, there's a lot of inspiration taken here from like the tangible interfaces we use today. So aircraft cockpits moving forward like this. And as far as rotating the panels around and moving them to positions that you want, one of the users said actually that they would like to have it snap at like 5 degrees. So everywhere you place it, it would snap to 5 degrees, just because they were like trying to align it up perfectly. So it was, but yeah, so it's like little things like that I think hopefully that answers your question a little bit. But
does it provide any accessibility benefits for people to be able to put it in the dimension that is easiest to use, I guess, for them? Yeah,
that's so that's where the next study really would be, is looking at users who do have some sort of accessibility issue regarding interaction. But a configuration file can be loaded, which will automatically place the panels to a position. So there's no reason that every time you go into the world just now, it's by default in a position, but there's no reason why every time you start it, it doesn't automatically load from a config, meaning that a user of a specific height or a specific ailment, configuration files can be used and shared between the communities that, so just kind of empowers the users again to like say, oh, I have a configuration file for the UI based off of this ailment. I think there's a lot of opportunity to explore there. Yeah. Cheers. Cool. Thanks.